This video is about geometry and number applications. Let's take a look at our first example. This one is about numbers. Notice that it talks about two different numbers. In fact, it says to find the two numbers. So we want to start by setting up our variables. So what we have here is one number is 6 times as large as another. So we have this one number that we want to start with. So when we say what should the variable stand for, let's say let x equal the first number. And it refers to another number, so I'm going to call that y. Let y equal another number. Well, now that we have our variables, next we need to think about the equations. And this is perhaps a little tricky because notice it talks about reciprocals. And how are we going to represent the reciprocal of a number? Well, let's think for a minute. The reciprocal of 5/8 is 8/5. But you could also say that the reciprocal of 5/8 is 1 over 5/8. And in fact, 1 over 5/8 is 8/5. But this means we could say that the reciprocal of x is 1 over x. That's what we're going to use when we go to set up our equations. We're going to use the fact that the reciprocal of x is 1 over x. Now we can set up our equation. We're going to start with our first sentence, that one number is 6 times larger than another number. So that means x is equal to 6y, 6 times as large as the other number. Now we need to talk about their reciprocals. Well, the reciprocal of x will be 1 over x. The reciprocal of y will be 1 over y. We want the sum of their reciprocals, so I need a plus here. So the sum of their reciprocals is 7/2. There we go. Notice that we have two equations in two unknowns. We're ready to start solving these equations. I see right away x is equal to 6y, and I'm thinking, you know, I could take that 6y and put it in place of this x. That's solving simultaneous equations by substitution. So that would give me 1 over 6y. And we have plus 1 over y equals 7/2. So I've taken these two equations and boiled them down to a single equation with one variable. There we go. Now I'm ready to solve this equation. How do I do that? It's a rational equation, so I need to think about the lowest common denominator. And I'm looking at each of these denominators, and I can see that 6y is the LCD. So I'm going to multiply through by this LCD. Technically, I'm multiplying both sides of the equation by 6y. And then distributing on the left-hand side. From a practical point of view, I'm multiplying each term by 6y. Now as I multiply, I can see that these divide out or cancel out. So here I get a 1. Here the y's are gone. I still have 1 times 6, which is 6. And on the right-hand side, well, 2 goes into 6 3 times. I have 7 times 3y. So here that is written out. I need to simplify this. I can add, of course, 1 plus 6, and on the right-hand side I'm going to multiply. So I have 7 equals 21y. I still want to solve for y. Here I'm going to divide by 21. Be careful. Notice the 7 is on top. So this is giving me y equals 7 over 21. That's 7 divided by 21. Don't reverse those. Okay, so I have y equals 7 divided by 21, and next we can reduce that to 1/3. So I found y. I still need to find x. I found y here. I need to find x. And remember, x is equal to 6y, so I'm going to use that. And I have x equals 6 times y, but I know that y is 1/3. So x equals 6 times 1/3, and that gives me x equals 2. And so I found x and y. Now what about our final answer here? X was not in the original problem. Really, x and y are not in the original problem. I did use x to find the solution, but x really shouldn't be part of the answer. I want to write my final answer in words. I want to make sure I'm answering the question that was asked. So since it said find the two numbers, here comes my answer. The two numbers are 1/3 and 2. By the way, we could do a little check. You can see that 2 is 6 times 1/3. That's one part of the check. And the other part is if I take their reciprocals, that would be 3 plus 1/2. That equals 3 1/2. And indeed, that is 7/2, so that also checks. That's just a little check of our final answer.